Welcome to part 2 of this 100 series Land Cruiser rear axle seal bearing and seal job. In this part, we're going to get the axle all put back together with new parts. We're going to get the axle back onto the vehicle. We're going to put the parking brake back together with new brake shoes. We're going to get the brake caliper back on, the tires back on, and the whole 9 yards. Unfortunately, as the day progressed, the wind picked up. Because we were doing some of the wrenching in my driveway, the wind noise was pretty bad at times. So I apologize for the messed up audio, but even though the audio isn't perfect, you can still understand the instructions I'm giving in the video. In a perfect world, I'd have a big shop with a 2-post lift, maybe a couple hot tool time girls and Daisy Dukes helping me out, but the reality is I'm working out of a 2-car garage at my house in San Jose, California, and I have a lot of stuff in here, tools, bicycles, and if I brought the truck in the garage to get out of the wind, then I would have very little room to work to get access to the press over here and get to my toolboxes. So for the most part, I like to keep the vehicle out in the driveway so it gives me way more room to work in my garage to do what I need to do. You will see in this video, there's some things that did not go to plan, which is kind of par for the course. And I will discuss those things so you can learn from us and not repeat the same issue that we had. With all that said, let's finish this job. So we're ready to drive the new axle seal into the housing. I have this race and seal driver kit from OTC. It's model 4507, and I picked one of the pucks that fits the diameter of the seal the best. So this one is labeled 4507-7. When you're driving in a seal, you want to have it close to the diameter of the seal. And then one extra thing that Gleb wants to do, and I approve of it, is a little extra insurance. So you use some of the Toyota form-in-place gasket. This is the 1281. It's the red stuff that is meant for transmissions, transfer case, differentials. We're going to put a little bit of this on the inside of the axle housing where the seal rides. So in case there's any imperfection of the axle housing, then the gear oil isn't going to get past that metal to metal connection. So it's just a little bit of extra insurance. You could put some on the seal, then drive it in, but we're thinking we'll make a little bit less of a mess if we actually apply it inside the axle housing and then drive the seal in. So I'm going to squeeze some in there, and then what I think I'm going to do is just smear it around the circumference with my finger until I feel like I have a good amount around the whole circumference, and then I'm going to come in with the seal and my driver and knock it in place. Another step that I suggest is take a little bit of brake cleaner and then clean off the outside of the seal really nicely so it makes a nice bond with the form-in-place gasket. Try to get your hands as clear of grease as possible because I have to grab the outside of the seal to insert it, a little bit at least. And then one thing that I didn't say yet is there is a natural stop. And so I'm just going to drive the seal to where it stops against the shoulder, and then I've driven it in fully. So there's no room for error with this installation of the axle seal. You drive it in till it hits the shoulder and you're done. So just get it in there as square as you can. One note of caution is that when you start driving it in, you might find that the seal starts going in a little crooked. Then you start to panic, and if you lift up one edge of the driver puck and you start driving with the knife edge of this instead of the whole flat face, then you could dimple the seal and then you'll have to pull it out and install another one. Whatever happens, keep the face of this driver puck completely against the seal at all times. If it starts going in crooked, don't worry, just keep on driving. It'll self-correct and then you'll finally bottom out. Okay, I heard a sound change. It starts driving in and the sound of the hammer hitting the tool has a certain sound, but when it starts to sound more of like a thud where you're bottoming out on the axle housing, you know you've driven it in fully. But I'm just gonna give it a few more taps to make sure. See, that sounds really solid to me. I'm pretty sure that's fully driven in. I'll remove it and then I'll just inspect my work. I'm gonna feel back here and I can feel the shoulder. I don't feel any gap back there. That is a fully driven in seal. So now we're gonna start assembling everything to get the axle put back together. The first thing we're gonna do is get the bearing inserted into the bearing case. I always like using grease to reassemble parts so they go together smoothly. So I'm gonna take some of this Redline CV2 wheel bearing grease and I'm gonna lubricate the whole inside of this bearing case. And because I love grease so much, I'm gonna actually grease the bearing too. And then I'm just gonna drop the bearing in here. Now, you saw how easy it went out, but I don't think I'm gonna be able to get this thing in with my hand. And on other applications, I've actually been able to insert the bearing into the case just with my hands, but I don't know if I'll be able to do that on this one. No, it doesn't look like it. So I've got it started in there and it looks fairly square. And then now we're gonna bring this over to the press and we're gonna drive it into the bearing case. So this smaller round press plate that Duane includes with the kit is perfect. It's 88 millimeters in diameter and the bearing is 89 millimeters. So it's just shy of the same diameter. So this plate is not gonna get stuck into the bore of the bearing case. I checked and it slides in with no interference. So I'm gonna place that on top. You can see it, I'm still pretty far away from the material. So what I'm gonna do is get the other Harbor Freight press plate and then stack them. And that's looking better. Because like I said, it's a pretty light press fit, I can just do this with my finger.
It's sliding in.
Oh, it's sliding in. So it found its perfect alignment with the bearing case and then it just started sliding in. That tells you right there it's not really a tight press fit. It's just almost perfect. So I'm just pushing it in with my hands. Just like that. So that's it. It's fully in. If I look from this side, I can see it's fully against the shoulder in here. So it is fully seated. And you saw it basically went in by itself. And you could see how far it gets driven in. So that's why you have to have a plate that won't get stuck into the bore. Like some people say, oh, you could just use the other bearing, but you'll see that if you try to do that, the old bearing would get stuck in there. So you can't use the old bearing unless you put this on a lathe or a belt sander and you took a little bit of the diameter off to where it won't get stuck inside the bearing case. So we have the bearing case with the new bearing installed, and with this unique pattern, you can't mess this up even if you tried. So you slide it in from this direction, get it lined up. There we go. So now we're going to insert the studs. Gleb decided to get new studs and new nuts, personal preference. You could reuse the old ones if you want. So his truck, his way. Insert one of the studs and then grab one of your nuts and get it started. Then go on to the next one. I have to say, this is kind of nice having new hardware because it's not sticky at all. Yeah. And then I'm going to draw them up into the bearing case with my DeWalt impact and a 17 millimeter socket. I just want to get them all started a little bit first. And depending on the strength of the gun, you just don't want to go too crazy, and that's why I'm using this 3/8 gun rather than a 1/2 inch. I don't want to strip it, so I'm just feeling underneath here with my finger to feel the gap between the stud and the backing plate. And because I'm a little bit timid and I don't want to go too far and strip them, I'm going to do the final tightening with just a 1/2 inch ratchet so I can really get a good feel when it bottoms out. So you could just grab onto the backing plate, hold counter pressure, and fully pull the stud into the bearing housing. So now we're going to install this seal. Again, I'm going to use a little bit of grease because why not? It'll make it easier to remove in the future. Just a little bit. And then I should be able just to install this with my hand. Okay, it's fully seated. You just watched me use some bearing grease to help with the insertion of the seal into the bearing case. And I don't suggest you do that. I suggest you put it in dry, and you'll understand more when I talk about the situation where this seal was able to walk out of the bearing case due to some grease pressure. So don't do what I did, just put this seal in dry with no grease. Now what I'm gonna do is I'm gonna lubricate the inside of the bearing races with the same CV2 grease, because we're now gonna be pressing the axle shaft through the bearing, and then we're also gonna get in place the outer retainer. So the axle and the outer retainer are gonna be pressed on next. I'm also gonna grease up the axle shaft really well with grease. The first parts are gonna drive on just underneath the snap ring groove. So I'm gonna lubricate it all really well. I wanted to share a problem that we discovered near the end of the job. So don't let this throw you. This is a axle from a 5th gen 4Runner, and the oil slinger is missing on this axle. So just imagine that the oil slinger is coming up right here. And then you have this seal, and this is the orientation. This side of the seal goes into the inner diameter of that oil slinger, and then this side slides into the bearing case, and then right behind here is a small pocket where the top of the bearing is. And I think because I liberally applied a bunch of bearing grease right here, as the axle is sliding through the bearing, that grease is being scrubbed off into that pocket between the seal and the top of the bearing. And I think because I had so much grease, the grease took up the available space in that pocket and then started applying pressure on the seal, and it pushed the seal out of the bearing case. And so what I want to suggest to you is I do believe you should lubricate this with some bearing grease, but just do a very, very light coating so you don't have what happened to us with a bunch of grease getting shoved into the pocket between the seal and the bearing, and then the grease wanting to push the seal off of the bearing case. So use some grease, but just do a very light coating. So now I'm gonna slide the backing plate with the bearing case over the axle. See if I'm tall enough to do this. Oh, there we go. Just like so. Push the bearing out. That might happen because it's not a press fit, so I have to pull this thing off. I decided I'm gonna do this a different way. This bearing keeps on sliding out of the bearing case, and usually I can get the whole assembly over here, but I was failing, so I'm gonna do it a little bit differently. We have the main tool captured with 2 of the Harbor Freight press plates. We put this sleeve in, and this is gonna be our driver sleeve. We put a washer on top, and that helps disperse the load onto the outer retainer, so the bevel will be facing downward. Put that on, and then we put the special washer with the concave side facing up, which will be against the bearing. And then we put the backing plate and bearing assembly onto these parts. So I'm going to come in with the axle shaft and slide it through, and then I'm probably going to have to tilt it a little bit towards me to get the axle flange to clear this. Slide the whole thing this way. There we go. So now as a team, we're going to raise the cross member up to where the bearing gets stuck at the beginning of where it presses on. Right there. And we're going to set it. And I think we can go up one more. We might need to build up the whole thing with more plates, because I think we're going to run out of room down there. You know what I mean? Same problem that we had tearing the parts apart. I don't think we're going to be able to drive it far enough, so we have to build this up. It's going to be kind of a pain in the butt. This is not ideal, but I'm going to push up on the assembly and see if he can sneak in some more plates in here. How much space do we have there now? A couple inches. Let's put in another 1-inch plate. So as you see, this is a little bit of a learning curve. So I'm liking that a lot better because I want to have ample room for the axle to be driven through the bearing and the outer retainer, and I'm not going to run out of real estate down here. So then I'm going to grab this plate that comes with the kit, and this is what the press appendage is going to drive against. This round plate fits the top of the axle flange face perfectly. And then I'm just going to center it on the press. I'm looking how the washer and the outer retainer, how they interface with this press sleeve. I'm just taking a look that everything looks kind of square, so as you're pressing the parts together, there doesn't have to be much correction. I'm just looking to see that it's fairly equal in relation to the press sleeve, the washer and the outer retainer. And that's looking better. It was pretty cockeyed before. So I'm happy with that. Now I'm going to bring the press down. That's loaded up. So this is going to be a situation where you keep on pressing until you meet significant resistance, letting you know that the axle is bottomed out on the bearing. And then when we pull the whole assembly off, when we see the snap ring groove above that outer retainer, we know we're good. So here we go. Okay, that feels like it loaded up. I think we're done. All right, so as a team, again, we're going to lower the assembly down as far as we can go here. It got stuck on there. Unfortunately, we came across a problem, and it's kind of weird because we've watched a video of somebody else using the exact same tool set with no issues. But what ended up happening is, see this press sleeve that comes with the kit? It interferes with the axle housing well before you're going to be pressing the outer retainer on far enough to expose the snap ring. So the press loaded up. I thought we were done pressing, but what happened is this was stuck onto the axle, so we had to use a bearing splitter and pull the damn thing off. So this is the problem. This alignment sleeve, this goes into the tool to where it won't fall off the top of the tool. So what we can do is I'm just gonna drive out this inner sleeve to where we could use this to press the parts back on. So I'll just relay that to Duane that he shouldn't include this alignment sleeve. He should just include the wider sleeve to do the press work and not include this, so nobody gets confused. And just like magic, here's the new sleeve design from Duane. He uses a outer alignment sleeve rather than an inner alignment sleeve. So this one will slide over the end of the tool, and this is a prototype. The sleeve fits a little bit tight on the top of the tool right now, so he's gonna make the sleeve just a little bit bigger for more clearance, because the sleeve kind of gets stuck on the powder coating, so he's going to clearance it a little bit more to where this fits on nice and easy. So this will be the new design, and nobody will have to worry about getting this sleeve stuck onto the axle like happened to us. So we're now at the point of correcting our screw up. We got that smaller sleeve off of the axle using a bearing splitter, and then now all we have on top of the main tool is the wider press sleeve with the washer. And so now we should be able to press down and complete the pressing of the axle through the bearing and the outer retainer and special washer onto this side of the axle. I think that's it. So now we can clearly see the snap ring groove above the retainer. And then we got a new snap ring. I'm going to use a different set of snap ring pliers and expand it and slide it down a little bit. Got to get it over the widest part here. There we go. I should be able to just push it on with my fingers, and there it went. Snapped in place, looks good. So now we're going to get the last two pieces put on the axle, the ABS tone ring and the inner retainer. Again, I'm going to lubricate the axle shaft and I'm going to lubricate the parts. So the ABS tone ring goes in this fashion with this shiny part facing up. The retainer doesn't have a particular side. It has a little bevel on both sides, so it doesn't matter in which orientation you put it on. And now this is going to be the point where we're going to use this special tool we made with the PVC pipe, and we're going to drive the ABS tone ring and inner retainer on to where this piece of PVC pipe fits snugly between the top of the outer retainer and the bottom of the ABS tone ring. So we'll have to bring this back over to the press. Again, it's the same setup. I have the press sleeve and the washer on top of the main tool. We have the assembly down low. I'm gonna pick it up and slide it in. And then we're gonna have to stop filming here. We can't get the camera on the tripod because one of the pieces broke. So we're just gonna have to stop filming and work together to get this thing up. Main tool, the wider press sleeve, washer, inner retainer, ABS tone ring. And then you can see the combination of press plates we have. We have the Harbor Freight ones, a 1-inch one and a 1/2-inch one. We have this piece of PVC pipe, and so I'm just gonna be pressing and then looking to see that I get this to where it's snug in between the ABS tone ring and the outer retainer, and then we know we've pressed on far enough. So here we go. Okay, it looks like about a 1/4 inch to go. You can do shorter strokes, so you could take like a partial stroke to where when you drive force with the handle, you're only going to move it a little bit. So you can short stroke it, basically. Ooh, it just needs a little bit more. I think like one more pump though will be too much, but I think I'd rather have it driven in a little bit too far than not enough because of where I saw the seal riding on the retainer. So I'm going to try to get it just a little bit more. There we go. And that just ended up driving in just a little bit more than it was. So it's probably like maybe a 1/2 millimeter off, but I think that's going to be good enough. So now what we're going to do is we're going to take the axle over to the rig. We're going to install the axle, and then we're going to see where the seal is riding on that inner retainer by making Sharpie marks on the retainer. So where the seal wipes away the Sharpie mark, that lets us know where the seal is riding. So now we're going to insert the axle. We've got Sharpie marks on the inner retainer, and this is how I like to install it. I support it with one hand so the weight of the axle doesn't go on the seal. And then we're just going to get the nuts cinched up, and then once the nuts are cinched up, we're going to turn the axle to see where the seal is riding. Okay, so we've got the axle fully bolted up. I'm going to spin it a bunch of times here and make sure we can clearly see where the seal is riding on the retainer. Okay, that should be good enough. Now we're going to take the axle nuts back off and pull the axle to see where it's riding. So you can see where it's riding. It's just a little bit lower of center. It's right about there. That's about where it was before. We're going to call that good. And we're going to now permanently put the axle in. There's one thing that we have to put on that we haven't put on yet, and that's the O-ring that goes over the end of the axle housing. So I like to put a little bit of grease on the housing where the O-ring's going to be. This is personal preference. And then you just slip the new O-ring over and just push it to the back. And the purpose of this O-ring is to be a weather barrier so water can't infiltrate the bearing. When the axle goes in, it mates up with the housing and it squeezes the O-ring in between the two pieces and it creates a seal. So this is the final time we have to mess with this side at least. When you get to the very end, you have to kind of pick up a little bit of the weight because the axle wants to be tilted downward and has to be pretty much parallel with the axle housing to slide into the differential. So you have to kind of pick it up a little bit. Now I'm going to give the honors to Gleb to put the nuts on, and then I'll look up the torque spec. The torque value for those axle nuts is 91 foot-pounds. We're going to replace brake shoes because they got gear oil all over them. You have this horseshoe clip that attaches the parking brake lever to the front shoe on both sides. Usually with these OEM shoe kits, they come with the horseshoe clips, but he didn't get them. So we're going to have to reuse these, which is kind of unfortunate. So I'm going to go in with a flat blade screwdriver and try to spread it out a little bit first. Okay, I got a little bit of a gap. I'm going to come in with a pry bar and knock it out further. Okay, I'm going to have to work at this for a while. More firm wax with the pry bar, and I was able to get it free. At the very end, I just got a screwdriver in between here and I pried it out. There is a little washer here, and it's like a little spacer. So we got to save this because we didn't get this either. And then we can take the parking brake lever off of the shoe. We'll get the new shoe in the vise. So then I'll slide this over. I think what I'll do is I'm going to put a little bit of grease on here. CRC brake and caliper grease. I'm going to lubricate the back a little bit, and then I'm going to lubricate the pin. So I'll slide the lever over. I'll get the tiny washer on there, and then I have to install the horseshoe clip again. I'm going to use a pair of slip joint pliers, see if I can slide it in place over the pin. There we go. And then I'm going to get it in the orientation where I could squeeze it in a little bit. Make sure that's seated all the way in there. Okay, that should be it. I can't pull it off, so I think the horseshoe clip, even though we had to reuse it, is going to work out just fine. We've got everything cleaned up really nice. The parts could be cleaner, but we're not looking for perfection. One thing I did grease and clean up is I added a little bit of grease on this removable side, and I cleaned out with some brake cleaner, added some of the CRC caliper grease, so anytime Gleb is going to need to do a brake adjustment, he can have a nice smooth functioning adjuster. You're also supposed to put caliper grease on 3 raised edges on both sides. You can see them. There's one here, there's one there, there's one down below, and then the same on the other side. One on the bottom, one in the middle, and then one at the top. And this is so the pads slide easier against the backing plate. And then you're supposed to put some grease here along both sides of the pin. Okay, that's all greased up. So now we're going to reverse our procedure. One of the last things we disconnected was the cable from the parking brake lever. And you'll notice we put some painter's tape on here to keep our greasy hands from getting the new shoes dirty. The lead end goes in on this side. Got it kind of started. I'll help with the needle nose. There we go. It goes like that. Okay, so that looks good. So I'm going to lock this one in with one of the hold down springs. So we have the U-shaped pin on the front side. I'm going to pre-assemble the parts onto the pin, and then I'm going to come in with a different tool to help me out. Put the first plate on with the hook facing the backing plate, put the spring on, put the outer plate on, and lock it in place. Gotta slide it through the slot and then turn it 90 degrees. There it is. I'm going to use this tool that I've used on 5th gen 4Runners and other vehicles. I'm going to get underneath the bottom plate, and then I'm going to lever up against this upper pin to compress it. And then I'm going to rotate the shoe into position. There we go. So that one's on. So before I go too far, I'm gonna get this spring hooked behind the shoe. It hooks right here. So I just gotta fish it in there and hook the front shoe. So I got that in there. I'm gonna get this in place. The spring goes to the back and the longer side, this side, faces outward. So I'm gonna lubricate this a little bit. I'm gonna slide it into right here on the front shoe. You see this slot right here? That's where it lives. We have this spring right here. It hooked into the shoe right here, and then it goes over this spot right here. So what I'm gonna do is I'm gonna get the star adjuster in next. I'm gonna lubricate in here a little bit too on both sides. And the side that adjusts faces the rear. So I'm gonna just place it in there and hope it stays there for me. Maybe not, it's not gonna do it. I think what I'm gonna have to do is get this spring connected first to the rear shoe. So now the bottom return spring is connected. Then I'm gonna fit the star adjuster in there. I'm gonna pull out on the spring a little bit and capture it just like that. And then I'm just gonna let it rest there while I get ready for the next step. I'm gonna pre-assemble the hold down spring on this side. Then I'm gonna get my tool behind here. I'm just gonna basically pull like this and then slide this up, get that in there, pull the tool out. I have to get this sucker in there. Star adjuster on the bottom got a little cattywampus. I gotta fix that. Okay, that's looking good. Okay, I'm gonna get this slid in place. I'm gonna hook up the bottom plate with a pick tool. See if I can pry it out. There we go. Got that in there. And then we got to get this spring hooked over that little nub there. See if I can do it with the needle nose pliers. So now what I'm going to do, I'm going to come in with a carpenter's clamp, holding the whole assembly together while I get the return springs on the top in place. So this just holds the shoes in firm. It makes it easier for you to get the return springs in place. So I remember the rear spring came off last, so it's going to go on first. And so you hook it in here. And then what I like to do is get a flat blade screwdriver, I get it over the pin, and then I slide the spring over this post right here. There we go. And then we got to get the other one in. There it is. So I'm just going to double check my work. I've got this upper shoe in between the two pads. I've got the return springs in place. I've got the hold down spring here in place. I've got the hold down spring on this side in place. I see the lower return spring in place and the star adjuster is in place. And so it looks like everything's good and this spring is in place. I think we're good to go. So we could take the painter's tape off. So we're gonna clean up the rotors really well where the pads connect up and on the inside where the parking shoes interface with, and then we're gonna slide it over. We slid the rotor over and it slides over pretty easily. And if you find like after a job like this that the parking brake isn't tight enough, then you could just do that thing that we showed you. You could jack up the rear end, take off your tire, take off the rubber plug, get it at the 6 o'clock position, come in with the long screwdriver, and then give it a few clicks. If you forget which way to turn it, well, if you turn it one way and it loosens up, then you know that was the wrong way, and then you can turn the star adjuster wheel the other way and get it to where the parking brake feels good to you. You don't want it so tight that you're actually wearing down the pads while you're driving. So as long as you can pull the handle and it's holding the vehicle, then that should be good enough. So we're not gonna mess with the adjustment of the parking brake. You can figure that out on your own. Now that we have the rotor on, Gleb is putting the brake bracket that houses the pads on with the two 17mm bolts. So the torque spec for the brake bracket 17mm bolts is 76 foot-pounds. Okay, those are both torqued to spec. Gleb already has the caliper slid over the pads, and the two 14mm bolts, one down here, one up here, that hold the pins in place, the torque spec for those is 20 foot-pounds. And he's holding the pin with a 17mm open end while he's tightening the 14mm nut with this torque wrench. There it is. We're going to get the brake soft line reconnected to the bracket on the backing plate. There's this small washer that has to go on. Going to slide it in and then get the clip in place. That's fully seated. Now I got to get this vacuum cap off and then pull the plug and get them connected as quick as possible. Okay, I got it started. Now I'm going to tighten it up. And this whole thing wants to twist on me again, so I'm going to support the back side with the 17mm open end. Okay, that's good and tight. Now we're going to install the ABS sensor. I'm going to clean it off, and then I'm going to use a little bit of grease on the O-ring so it's easier to slide out the next time if he ever has to remove it. Okay, now plug it back into the axle. Ah, damn, it's so fucking hard to get it in there. That's what she said. Why is this thing so hard to get in there? Sucker just fits tight. That's all there is to it. Got to get the little 10mm bolt in there. And I'm just going to cinch this up with my 1/4 inch ratchet, go by feel. And that's good enough. Now I'm going to get the parking brake reconnected to the bell crank. Remember, you want this special metal clip in there. Don't forget that. Slide it over, line up the pin. The pin went in from the top. There we go. Then we got to slide the little clip in. Just like that. And that's pretty much it. So that's one side, and now we got to complete the other side. We did the press work on the other axle, the shorter axle, which is on the passenger side. Everything went as planned, with the exception of finding out that that one seal that goes into the bearing case pushed out a little bit on us because I used too much grease to assemble the parts. When we finished the press work for that second axle, it was getting kind of late, and Gleb was pressed for time. He's got a family, and he was getting some pressure to get home. So there's some things that we didn't cover that I'm going to talk about right now. Number one is the bleeding of the brakes. With the 100 series Land Cruiser or an LX470, all you got to do is turn the key into the on position, which powers the electric brake booster. Then, with the help of a helper, your helper pushes pressure on the service brake while you go to the brake caliper. You would want to start at the one furthest from the brake booster, which would be the passenger rear. You open up the brake bleeder with a 10mm wrench, and you just let the fluid flow to where you don't see any air bubbles coming out anymore, and then you close off the bleeder, and then you could tell your helper to let up off the service brake. Then you would go to the driver's side rear and do the same procedure. Just be mindful that if you're going to let a lot of brake fluid flow out of the bleeder, make sure that you don't drop the level at the hydraulic brake booster below the minimum level. So if you drain out a ton out of the right rear caliper, then before you start the left rear, go back to the brake booster, top off the brake fluid, and then do that one. And then once you're done with the bleeding procedure, make sure you top off the brake fluid to the max level. The other thing that we did that we didn't show is filling the rear differential with gear oil. Gleb decided to use a synthetic 75W90, but you could also use 80W90, and it can be conventional. It doesn't have to be synthetic. You could also go for something like this. This is recommended by the guys at East Coast Gear Supply. When they rebuild a differential for somebody, they recommend using conventional 85W140, a much thicker gear oil than 75W90 or 80W90. So that's another option. And according to the owner's manual, the capacity is 3.2 quarts. But regardless of what the manual says to fill it, anytime you fill a differential or a manual transmission or a transfer case, you fill it with gear oil until you see the gear oil spill out the bottom of the threads of the fill hole, and then you know you're full. So knowing the amount it holds just helps you out for when you go to the store or you order your gear oil online. But fill the differential to where you see the gear oil spilling out of the fill hole, and make sure that you're on level ground when you're doing that. If you're at a slant, you're not going to get an accurate amount in there. You're either going to get too much if you're slanted downhill with your front end lower, or you're going to get too little if your back end is lower. So make sure you're on level ground for the filling of your rear differential. And then with those drain and fill plugs, I recommend that you use a fresh crush washer for both of those plugs so you don't get a leak after you're done. Another thing we didn't show is getting the wheels back on and torquing the lug nuts to spec. A good torque value for the lug nuts is 85 foot-pounds. One last thing we did is we replaced the breather on the top of the differential. Quite often, the reason why the axle seals failed was because of a blocked up breather. As the gears are turning in the differential, they create heat. And with the heat comes an expansion of the air, and that pressure needs to go somewhere, and that's why you have a breather on your differential, on your transmission, transfer case. So it gives the pressure a place to go out and not blow out seals. So if that breather blocks up, the air pressure is going to take the path of least resistance, and that's going to be pushing out the axle seals, and then the seal fails, and then you have to do the job. We didn't show that, but it's very, very simple. You just look up at the top of the axle, you'll find the breather. I'm pretty sure it's a 14 millimeter. You spin it off, and then you spin a new one in it. Now I'll go through a summation of what I thought about this job. For the most part, this job went pretty well. There was a couple hiccups, and that was the press sleeve combo that we got from Duane, but I shared with you the error I did by not checking to see if that alignment sleeve would interfere with the widest part of the axle. I blame myself for that. I don't blame Duane. So I should have checked that before starting the press work, but I didn't. So that's on me. But I did show you that new sleeve design that Duane came up with that outer alignment sleeve, to where there's no chance of what happened to us with one of the sleeves getting stuck on there. With that outer sleeve as an alignment sleeve, you're not going to have the issue we had. So that was the first hang up. Another issue is that I used too much grease on the parts to assemble them, and it caused that outer seal to push out of the bearing case. The interesting thing is I've done tons of rear axle seal jobs, mostly on third generation 4Runners. I've probably done at least about 14 sets of those axles, maybe more. And I always liberally grease all the parts, and I've never seen the similar seal on the third gen axles pop out like that from grease pressure. But what I'm thinking is that the pocket between that seal and the bearing on the third gen 4Runner axles, which would be the same for first gen Tacoma axles, that pocket is bigger, and so the excess grease scrubbing off the shaft of the axle isn't causing any issue with that seal. And just to let you know, after pushing it back in with a bent screwdriver as a tool to get it re-secured to the bearing case, it has stayed put, and so it's not an issue. But like I said in the video, only use a very light coating of grease to put the parts together, and don't use the amount that I did. I really smeared that grease on like crazy. So just use a light coating on all the parts and you'll be good to go. Now for the final thing that we found doing this job, and it was serious pucker factor. And what that was is when we went to insert that passenger axle, we couldn't slide it all the way into the differential, and we're racking our brains going, what the hell is going on? So I used my headlamp and I looked down the axle tube, and I see there's some type of obstruction. And I'm like going, what the hell is that? What the hell could have shifted in there in the third member? I was like totally dumbfounded. I tried to call George at Valley Hybrids because he's an expert in Land Cruisers, but he must have been busy. He couldn't take my call. So I called another friend, Nick, at Yoda One Performance, and he answered my call, and I asked him what could be that obstruction, and he told me it must be the oil baffle in there. So the differential on these 100 series Land Cruisers, it has an oil baffle to help keep the oil around the ring and pinion gears and the bearings. And from what I understand from doing a little reading, I found a thread on ihatemud.com. There's a couple clips that are spot welded to that baffle, and maybe the spot welds fatigued and broke, or maybe the clips broke themselves. I don't know, because I really didn't want to pull that third member out to find out. That was going to add a lot of work for our job, and it was getting really late. So his rig would have been stuck at my house if we were forced to do that. So what I did to fix the situation is I got one of my really long pry bars, probably about this long, and we lowered the truck really close to the ground, because what I found when I went in there with the pry bar to try to recenter that oil baffle with the axle tube, it kept wanting to rock forward because we were at a slant on my driveway. So Gleb and I lowered the truck really low, like maybe like 7 inches from the ground to get it more level. And then I was able to carefully manipulate that baffle to where it was fairly aligned with the axle tube. And then I inserted the axle, and thank God I was able to get it through that oil baffle and into the differential, and we were able to bolt up that axle. Nick told me that it's not a super common thing, but it can happen. So if you have the same thing happen to you, that's what I recommend you do. Make sure the truck is level, get in there with a long tool of any kind, whatever it is, and try to manipulate that oil baffle to where it's pretty much in line with the axle tube so you can insert the axle. So there it is there. That was the really big problem that I was thinking, like, my God, we're stuck. And we're gonna have to now remove the drive shaft, take the third member out, and try to fix this oil baffle. So I'm stoked that I didn't have to resort to that, and I was able to get Gleb home that night. On the topic of that oil baffle, I will link a thread from ihatemud.com that sort of discusses it. But if you have any personal information on that oil baffle and the fixes people have to do to rectify that problem, go ahead and leave a comment, and I'd like to hear what you have to say about it. And I'm going to try to have a conversation with George at Valley Hybrids to learn his take on that oil baffle and how you can fix it so it doesn't occur to you. Again, I apologize for the audio for this job. I can't control the weather, and we were working out on my driveway, and the wind was just howling, and it screwed up the audio. But like I said at the beginning of this video, you still can understand what I'm saying, but the audio isn't optimal, so I apologize. With all that said, I thank you for watching Toy at a Time with Timmy the Tool Man and Sean, and special guest Gleb. Thank you for watching. Thank you for subscribing. If you haven't subscribed yet, click that subscribe button, and also click on that notification bell if you'd like to be notified when we put up new content on our channel, which we are always putting up very helpful and cool and sick mods kind of content on our channel. So don't miss out. Peace out, happy wrenching, sick mods, and sick rear axle seal and bearing jobs on your 100 series Land Cruiser or your Lexus LX470. Bye-bye.